Let us solve given LPP using simplex method, and this is a simple simplex method, meaning we have a less than or equal to condition as the constraints are given, and generally they would ask the question also with the keyword, use simplex method directly. So whenever the question is given, we are supposed to first check according to the algorithm that whether it is a max z question or a min z question, and if by chance the question is given as min z, then obviously that we convert the question in general English that majority of the times they would be using. And the question is, we have an objective function called as max z equal to 4x1 plus 10x2, and these are subject to the constraints, subject to the different constraints given are 2x1 plus x2 less than or equal to 50. Then we have 2x1 plus 5x2 less than or equal to 100. Then we have 2x1 plus 3x2 less than or equal to 90. These are the different constraints that they have given, and also there is a non-negativity condition which is mentioned. x1, x2 are two variables which are always positive. This is the non-negativity constraint. So this is the given question. So our objective first is to check whether the question is max or min. If it is converted and we know it, and in the second step we have to check the constraints, whether we have all the constraints to be as less than or equal to type. So that means this is a normal simplex method and easy to solve. Just follow the algorithm of simplex method to attain at the initial basic feasible solution. The next step is we bring the actual given LPP into standard form. So how do we do that? How do we bring that to the standard form? Is that we have to write down the objective function at the first step as it is 4x1 plus 10x2. Now the constraints that we have 2x1 plus x2. Since it is less than or equal to, it is clearly understood that we have to add a slack variable called s1 so that it is equated to 50. Same way we have the second inequality. Let us convert it. It is 2x1 plus 5x2, and we introduce one more slack variable called as s2, and then it is equal to 100. In the third inequality again we have 2x1 plus 3x2, and we introduce the third slack variable called as s3, and directly we equate it to 90. So whatever are the new variables that we have introduced, like s1, s2, s3, these are the three slack variables that we have introduced. This is to be represented even in the objective function, but the main idea here is we are not changing our objective. There is no way that we forgo the actual objective that we have. We are supposed to follow the objective or attain at the objective, but indicate all these variables with no change in the objective. That means whatever variables are introduced will be indicated in the objective function with a zero cost. So the table